journey right around the world. We're talking to people who are trying to tackle some of the biggest challenges mankind is facing over the next decade. Welcome to Horizons. With an increasingly overcrowded planet, increasing affluence and more consumption, what to do with the ever-growing mountain of waste will be one of the major challenges in the coming decade. Globally, the amount of solid waste material generated in urban areas annually has almost doubled over the past decade, and as city populations continue to grow, experts estimate a further increase of nearly 1 billion tonnes per year by 2025. With space for landfill sites running out and tighter regulations on greenhouse gas emissions from waste incineration, it's clear we have to find better, indeed more sustainable ways of dealing with our waste. Later, Saima is in Bangalore, where they're making roads out of waste plastic. But first up, we're heading to California.
Now, I've come to the state's capital, Sacramento, to find out how the USA's 16,000 wastewater treatment plants can be transformed into chemical production facilities, recycling sewage sludge into useful biodegradable plastics, eliminating two major environmental problems in one stroke. Our global society continues to flush a massive source of carbon into its sewer systems. 7 million tonnes of dry, solid human waste are produced in the US alone every year. Turning this underappreciated waste stream into a useful product is the goal. So, Greg, it all starts here, really, doesn't it? And apart from the very distinct smell right now, it is pretty whiffy. But tell me about the waste that you guys deal with here every single day.
Right. We treat 15 million gallons a day of sewage that comes in from our local communities. The water that is produced here is clean, and we provide it to farmland around our area to grow crops.
The wet sludge is dumped at landfill sites. However, a proportion of the carbon-rich waste is now used as a resource for the emerging bioplastics industry.
We're very excited because this is something that we've not heard that any other facility has attempted. So converting now from a waste product into a reusable product that is plastic was really exciting for us, and we're very enthusiastic about the progress that's being made on this work.
I'd like to go and take a look now at the lab and see where that stuff's going to. This is where Sacramento-based Micromidas comes in. It's already raised millions of dollars in investment funding to build a pilot biorefinery turning human waste into plastic. So, Ryan, this is where all the raw sewage that you can make use of comes into your lab. What happens to it?
Once a week, we have a sewage truck that comes in through this door, and we pipe the sewage into this tank, where it sits and it churns for a couple of days. And in that process, everything breaks down into sort of a big nutrient soup. And so what we do is we take that soup and we run it through this machine right here.
So what, do they come out of separate parts? So
yeah, so solids plop out here, and we've got a line of liquid that runs through, and that has all the good nutrients that we feed our bugs to make the plastic.
Natural bacteria produce plastic called polyhydroxyalkanoate, or PHA. It's a type of polyester made from sugars by enzymes and is produced by the bacteria to store carbon.
So as you can see, we take that, basically the broken down soup, I'll call it, and it looks something like this.
Right.
This still has some suspended solids in it. Wow. And so we run it through that machine. That's what we call our nutrient broth. Yeah, and that's what we feed our organisms. The broth we then put into this fermenter right here, this reactor. And then in there, we put our bugs that make the plastic, and they swim around in there for about 2 or 3 hours. And over the course of that time, we induce a stress where the organisms take up all the carbon, all those nutrients, and they turn it into a plastic. You're used to seeing large, complicated chemical manufacturing plants. Every little microbe is a chemical manufacturing plant. And so all the complexity is there. And so that's what we focused on in the development.
In terms of the science of it all, where exactly does the bacteria come from? Is it in the waste, or do you find it from somewhere?
So we do. We've got essentially our microbiologists. Some of them are bug hunters. They go out into the environment, places like riverbeds, waste streams, wastewater treatment plants, soil samples, and we look for places where there's an influx of carbon, and then carbon and nutrients disappear, and then they show up, and then they disappear. And in that environment, we find sort of a rich number of bugs that have the ability to store carbon as plastic. Each species we find, we run through a battery of tests to determine which ones make plastic most effectively. And we've essentially acquired a library. And once our biologists find a bug that's interesting, we bring it over here and put it in this fermenter, a series of fermenters that are hooked up to computers. And from there, we monitor things like the temperature, the pH, how long does it run. And over the course of that process, we figure out exactly how to sort of induce this response where they make plastic. So, in fact, if you want to see some granules of plastic inside a bug, I've got some on a microscope.
Oh, gosh, I'd love to.
Absolutely. Go ahead, take a look. They started out as little rods of bacteria, and they sequestered all the carbon in their environment, and they plumped up into, as you can see, little spheres. And there's a little granule of plastic inside each little cell body.
Those round things in there, that's bacteria full of plastic.
We then go harvest them, separate the bacteria from the plastic, clean it up, and then we've got a sellable product. Once the bacteria are full of the plastic, we essentially dry them out. As you can see here, this is just bug bits with plastic insides. Then from there, what we do is basically extract the plastic, so we end up with just white polyester resin.
Oh, so this is plastic?
Yeah, this can be pelletized and then sent to become a bottle cap or a fiber or a foam.
Bioplastics are more sustainable because they can break down in the environment faster than fossil fuel plastics, which can take more than 100 years to degrade. They still account for a minuscule proportion of global demand. Most bioplastic tech is relatively new and isn't currently cost competitive compared to fossil fuel plastics. But as the price of oil continues to rise, they could provide a more sustainable alternative. So, Peter, I've seen the plastic as it appears in the lab, but actually, what can you do with it?
We can make most of the products that are made with a broad variety of plastics today. We have some advantages. Our materials is a little more flexible, and that gives us some processing advantages. And then when you're done with it, you throw it away, and it completely biodegrades.
You can make this from that?
We can make something like this.
Yeah.
And really what I want to mention is that this is packaging materials. This is also styrene, but it's foamed. We can foam our PHA as well.
Is this kind of plastic going to be more expensive if it's unique, it's something that your company's come up with, and it's biodegradable? All of that must come at a cost.
We'll figure it'll be about in the same range. In some cases, maybe even cheaper.
Is it going to be commercial very soon?
We anticipate about 2 to 3 years. We've identified literally hundreds of millions of metric tons of waste material that are eligible for this process. Well, that's in the U.S. And then you go worldwide, it's even greater. So we're very excited about the prospects and bringing a true environmental and product benefit to the world.
It's hoped that these fossil fuel-based plastics will all be PHA in the coming years. There are a number of commercial ventures now attempting to scale up production across the globe. The goal is to make it a real competitive alternative.
The global waste business is thought to be worth some $400 billion a year. It's a growing business. Recycling is also likely to grow, creating substantial jobs and resource savings. Join us after the break to find out more.
Yo me levanto a las 5. De ahí viene mi papi ordeña. Ya volteo, de ahí hace queso. A mí me gusta que juegue juego con las vacas y que mu te están diciendo, yo no sé. Mi papá me ha contado que el queso lo hacían con el cuajo de vaca. A veces el queso salía sucio y se dañaba y no servía, tocaba botar. Perdió el trabajo y perdió la plata del queso.
En nuestra región hay mucha pobreza. La ineficiencia, podemos decir, de nuestros pequeños productores por la falta de una tecnología adecuada para su producción, pues lo viene dejando en desventaja.
El queso ahora se hace con un cuajo que es higiénico. Yo no sé de qué será ese cuajo porque ahora no se desperdicia así como antes.
El coagulante Danisco-Dupont es una enzima que modifica la proteína de la leche para coagularla y obtener queso. Es un producto de alta calidad, fácil de manejar.
Uno le echa el cuajo, espera ahí unos 30 minutos, 40. Y cuando uno vaya, está cuajado así la leche. Parece magia. Yo ese señor no lo conocía, pero él vino y nos enseñó a usar. De pastillita no.
Hacemos reuniones periódicas para entrenarlos sobre la mejor forma y más productiva de hacer el queso.
Porque le está generando mayores ingresos y lógicamente que ha mejorado el nivel de vida.
Que estoy muy agradecido con él por todo lo que me ha dado.
One of the fastest developing nations in the world, with a population of over 1 billion and growing. India's waste production looks set to grow significantly in the years ahead. The city of Bangalore generates around 5,000 tonnes of mixed waste every single day, from broken TVs to plastic containers, most of it strewn across the streets, or it ends up on mountainous landfill sites. That, though, isn't the case for all of it. Around 50 tonnes of this daily discard actually has an interesting new afterlife. Plastic is collected, shredded, and eventually turned into roads. This is the start of the plastic road process. We're off to collect ourselves some plastic. More than 1,500 kilometres of new roads or resurfaced old ones now contain discarded bags, bottles and cartons, absorbing thousands of tonnes of plastic waste in the process. For every kilometre of road, 2 tonnes of plastic's required. Right, so this is it. This is where it all starts at the beginning of the day. They're going to take all the plastic out of this and make use of it, make roads out of it. As well as the auto rickshaws are bin women or bin men that collect everyone's household waste every morning. Now, KK Plastics pays them 6 rupees a kilo to segregate the waste and collect plastic. So we've collected all of our plastic and we brought it to the factory for the next step. Mr. Khan, I've been out with your boys this morning collecting all of this plastic for you. So what happens with it once it gets here?
We take this into a cleaning mission.
So they're literally taking all of this rubbish, throwing into that, spins round. These machines clean the littered bags, bottles and food packaging with blasts of air. The aim of the tumble dryers is to remove foreign particles.
Out of this, we'll make flakes, and that flakes will be taken to the plant. Another one plant is there, where it will be mixed with the bitumen.
The plastic is mixed with asphalt at 150 degrees Celsius to produce polymerized bitumen. The plastic acts as a binding agent, helping road surfaces hold together better at higher temperatures. And since plastic is water resistant, the roads don't get waterlogged, have fewer potholes and need repairs less frequently than conventional roads. And where did the idea of using the plastic bags in roads come from?
See, we had some basic fundamental knowledge about plastic, how it is produced. So ultimately, this is a petroleum product. Plastic is a petroleum product. Again, bitumen is a petroleum product. Though we thought, if plastic could go into bitumen, it would be a good idea.
What are the benefits of mixing plastic with bitumen?
See, one aspect is it definitely improves the performance of the road. That is the longevity of the road. Second thing is the very plastic was a problem. It was a big challenge to municipal solid waste. If this is not eliminated or removed at source or from the garbage, the whole garbage would not convert into biofertilizers.
Can this process be emulated or adapted for another country or completely lifted and you could build a road exactly in the same way anywhere in the world?
Yeah, we can.
I went to see how this innovation is literally being rolled out across the city. I wouldn't stand in my way if I were them. Plastic roads are more durable than bitumized surfaces. They dry quickly and can be used within a few hours of laying. Polymerized bitumen is not a new compound and has been used for paving in places other than India. Typically, it's mixed with new plastic, making it an expensive venture with no environmental benefits. Mr. Khan's innovation was one of the first in India to use waste plastic. These roads compare with the old ones you were using?
Life expectancy of a road from 2 years has increased to 5 years.
How much does an average road cost to build in the city of Bangalore?
The cost is around 30 million per kilometer.
30 million rupees.
Yeah, 30 million.
And how much is it with the addition of the top layer of plastic?
That is about 0.6% increase in the overall cost of the construction of the road.
Just 0.6%?
0.6%, yes.
Do you think it's worth that cost?
Sure, it is really worth it to use plastics in roads.
The Goan government has rolled out plastic roads. The city of Pune is also looking at the technology. Getting more state government agencies involved is key to its success in India. Reusing some of the estimated 50 tons of daily discarded plastic in Bangalore is so far proving to build stronger and longer-lasting roads. But plastics are just a small part of the growing waste problem facing India as its economy and population expands. This is one of the many massive rubbish dumps spread across the sprawling metropolis of Mumbai that receives its share of around 8,000 metric tons of waste generated every day. If Mumbai continues to expand at the rate it has over the last few decades, there'll simply be too much waste generated and not enough space to store it all. Local waste management is going to be crucial if the city's to cope. It's the reason why some housing districts like this one in Chembur are now taking up the challenge. So what prompted you to work on this waste management project?
The city is getting very dirty, so we must do our little bit, and that is to segregate waste so that there is no strain on the municipal system.
Each day, 600 kilos of waste are produced by this housing estate from 500 families. It's responsible for its own recycling. The goal, to achieve zero waste. So did all the residents agree to do it, or was it quite a challenge?
Many people didn't understand, they didn't understand the importance. So I think after 1 year, more or less, it stabilized. But even now also, sometimes some people make mistakes. We try to tell them it is religious duty. Try to put a kind of that you must do it perfectly.
A women's collective, once rag pickers on Mumbai's dumps, gather the rubbish. Biodegradable wet material, which makes up to 60% of household waste, is composted on site, while dry materials recycled.
Now they put it here and they spread it. So you mix, sometimes at the bottom there is a cow dung, small quantity, which is where the culture, that is the bacteria or the earthworms thrive. And then they keep on converting all the waste, which is like a soil.
The compost is used for gardening. Schemes like these are now running successfully at 40 places around Mumbai. I've seen how waste can be used for compost. Now I've come to the Tata Institute of Social Sciences to see how it's being used on an altogether bigger and more scientific scale to produce biogas. Dr. Kale, where exactly have you brought me? It's very noisy here and there's lots of machinery.
We are actually standing behind a canteen of Tata Institute of Social Science. They want to make sure that none of the kitchen waste resource is going back to the dumping yard. They will treat it within their campus. They will generate gas out of that, which they will use in their canteen.
The Institute funded the Zero Waste Campus, costing nearly $20,000 for the biogas plant. Yet a unit like this pays for itself within a few years.
This is the resource, what I am talking. Normally we call it waste because nobody can use it. We are using it here. Then it gets digested partially. Through this channel, then it flows into the main digester.
Dr. Kale wants each ward in the city to set up a biogas reactor. Here, kitchen waste is broken up into small pieces before natural enzymes digest it to produce 15 kilos of biogas and 40 kilos of compost a day.
This is a floating dome, and this floating dome is full with biogas.
Wow,
so as the biogas is generated, the dome lifts up. The dome is around 1.5 tons, and that biogas is coming up. Then it is flowing through this.
Let's follow the pipe, see where it goes. It's a direct pipe, straight to the canteen.
Now this is the pipeline which comes into the kitchen.
That is a roaring flame. Can you believe this is creating that? This is not waste. It is a resource, and this is proof. Can be used. Now, you're using this on a very small scale for the canteen, but what about on a bigger scale? Because we're in a mega city.
And the solution is the same. Because even in mega cities, you will find some small pockets, like establishments, schools, colleges, hostels, hospitals, where they must be producing these big canteens. Decentralized solution for the decentralized problem.
Reduce, reuse, and recycle. They are the watchwords of the environmentalists, but they're becoming more applicable to all of us, especially as our natural resources become more scarce. We could think of our waste not as something to be thrown away, but as a valuable resource in itself. This isn't just a topic for green politics. This could become a major business opportunity in the future. And come the year 2050, we could even be mining our mountains of waste.